Good morning, students. Once again, I welcome you in another episode of chemistry subject. Okay, already yesterday we discussed about the meaning of chemistry, branches of chemistry, and the importance of chemistry. Okay, and today we will discuss about matter and its nature. So, listen carefully and be attentive in your class. Okay? So, first of all, we will know about what is matter. Okay? Anything that occupies space and possesses weight is termed as matter. The amount of matter contained in any object is known as its mass. Matter can be seen, tasted, smelt, or felt. Matter can neither be created nor destroyed. It can only be changed from one form to another. A substance, another term loosely used for matter, is a material, all parts of which are chemically identical and all samples of which have the same composition. Understand? First of all, we will know about its classification. One way of classification of materials or matter is into pure substances and mixtures. Another way is to classify matter as elements, compounds, and mixtures. The two ways are related to each other as example, here it is given matter. In a side it is given pure substances. Beyond it, its subpoints are elements and components, and in the right side, mixtures can be separated by techniques like filtration, sublimation, decantation, chromatography, crystallization, etc. The matter encountered every day is almost always a complex mixture of various substances. Example, air is a mixture of more than 5 gases. Petrol is a mixture of several hydrocarbons. Drinking water is a mixture of pure water and several salts. Milk is a mixture of water, proteins, vitamins, minerals, and carbohydrates, etc. There are few examples of use of pure substances in daily life. Example, copper used in electrical wiring and distilled water used in car batteries. Did you understand? Okay, then now we will go to another point, and it is about composition of earth. The crust of earth or lithosphere includes the solid surfaces of the earth to a depth of approximately 30 km. The lithosphere is composed of three principal types of rocks. One is igneous, second one is sedimentary, and the third one is metamorphic rocks. The parent material of all these type of rocks is magma, a form of rock, mobile at high temperatures, that contains molten rock along with considerable amounts of gases such as steam, HCl, CO2, and H2S. Most magmas solidify below the surface of the earth, but when they erupt through cracks and fissures in the surface, they form what is commonly known as lava. Analysis of the crustal composition are summarized in Table 1. It can be seen that the first 8 elements make up almost 99% of the Earth's crust. Not only is oxygen the most abundant element by weight, but it is also accounts for more than 90% of the volume of the crust. It is interesting to find out that elements common to everyday experience such as carbon, copper, zinc and nitrogen do not appear among the 10 most abundant elements. Okay, now we will discuss about a table 1. In table 1 it is given most abundant elements and its percentage by weight in the earth's crust or rocks. So here given O, its weight is 46.6%, Si, its weight is 27.7%, Al 8.1%, Fe 5.0%, Ca 3.6%, Na 2.8%, K 2.6%, Mg 2.1%, Ti 0.44%. H comprises of 0.14%, P of 0.2% and Mn 0.1%. Okay, the hydrosphere is composed of the fresh and salt water portions of the earth along with solid state water in continental snow and ice. According to estimate, there are about 273 liters of water for each square centimeter of the earth's surface. Of these, 268.4 liters are in the ocean, 0.1 liter is fresh water and 4.5 liters are in the form of ice and snow. Okay, then now we will go to another table 2, and in this table we will see most abundant species in seawater and its percentage of total species. So first one is solute and next one is its percentage. So chloride or Cl, its percentage is 55.05%, sodium or Na, it is 30.61%, sulfate or SO24 7.68%, magnesium or Mg 3.69%, calcium or Ca 1.16%, potassium or K 1.10%, bromide or Br consists of 0.19%. Okay, then the next point is element. So what is an element? An element may be defined as a substance which can neither be broken into nor built from two or more simple substances by any known physical or chemical method. Example, copper, silver, hydrogen, carbon, oxygen, nitrogen, gold, iron, etc. There are about 109 elements known to man. Okay, then the next point is compound. So what is a compound? A compound may be defined as a substance which contains two or more elements combined in some fixed proportion by weight and which can be decomposed into two or more elements by any suitable method. The properties of a compound are entirely different from those of the elements from which it is made. Some common examples of compounds are water, sugar, salt, aspirin, chloroform, alcohol, and ether. The composition of a particular compound will be the same no matter from that source is obtained. For example, water obtained from rain, wells, oceans, rivers, or mountains has the same composition, that is H2O. So now we will discuss about table 3. In this table we will discuss about symbols of important elements. Okay, in first column it is given elements and then in next column it is given about symbols. So first one is aluminium, its symbol is Al, antimony is Sb, argon Ar, barium Ba, boron B. Bromine, Br. Calcium, Ca. Carbon, C. Chlorine, Cl. Chromium, Cr. Cobalt, Co. Copper, Cu. Fluorine, F. Germanium, G. Gold, Au. Helium, He. Hydrogen, H. Iodine, I. Iron, Fe, or ferrous. Okay, after knowing the elements and its symbols, now we will discuss about some elements and compounds. First one is ozone. So, it is an allotropic form of oxygen and contains 3 atoms in the molecule. It is a gas, very active chemically, and is a powerful oxidizing agent. Ozone sphere is the layer in the upper sphere that consists of 15 to 30 km above the Earth's surface. It is responsible for absorbing a large proportion of the sun's ultraviolet radiation, which is otherwise harmful to living beings as it causes damage to eyes and also causes cancer. Okay, next one is sulfur. It is a non-metallic element which occurs in many allotropic forms. It is mined by a special technique called Frasch process. It is used for vulcanizing rubber and in the manufacture of dyes and explosives. Compounds of sulfur are very useful as medicines, drugs, and insecticides. The most important compound of sulfur is sulfuric acid, or its chemical formula is H2SO4, as it is extensively used in the modern chemical industry. Okay, next one is phosphorus. It is found in rocks, minerals, and in animal bones. It can exist in several allotropic forms. Two of them are the well-known and phosphorus and red phosphorus and white phosphorus. One of its very important use in the fertilizer industry, red phosphorus is used in safety matches. It is also capable of forming a large number of compounds. Phosphorus is an essential constituent of all living animals as it is present in DNA and RNA, besides being present in bones and teeth. And the next one is silicon. It is the most abundant element of the earth after oxygen. Mica and silica contain silicon. It is a semiconductor and finds wide applications in the electronic industry. It is used for making microprocessors for applications in computers. Silicon is also used for making waxes, grease, and polishes. Polymers containing silicon also find applications in the manufacture of tubes. A useful compound of silicon is carborundum, silicon carbide, SiC, which is used as an abrasive and as a lining in furnaces. Okay, and then halogens. This is class of compounds of mainly 4 elements, viz. Fluorine, chlorine, bromine, and iodine. These are very reactive elements, so they do not occur in free state in nature. Chlorine is used in the manufacture of bleaching powder, disinfectants, and also as a germicide in drinking water. Compounds of fluorine are used as cooling agents in refrigerators, that is freon. The fluorinated polymer Teflon finds numerous uses. It is tough and fire resistant. Halogenated organic compounds are extensively used in organic synthetic reactions. Okay students, did you understand up to this much? After this we will discuss about mixtures. Okay, so what is mixture? A material obtained by mixing 2 or more substances or elements or compounds in any indefinite proportion is called a mixture. The properties of the components in a mixture remain unchanged. Some common examples of mixtures are milk, petrol, air, food, earth, and sand. Mixtures can be divided into two types: homogeneous, in which the composition is uniform throughout and it exists only in one phase, that is solid, liquid, or gas, and heterogeneous, in which different compounds are not present uniformly and it may exist in different phases. And next one is separation of mixtures. How we can separate mixtures? Some methods of separation of mixtures are described here. First one is sublimation. In this process, a solid substance passes directly into its vapors on application of heat. The vapors, when cool, give back the original substance. This method can be used for substances which are sublimable in their separation from non-sublimable materials. Some examples of compounds that are sublimable are naphthalene, iodine, and ammonium chloride. Another type of separation is sedimentation and decantation. This method is used when one component is a liquid and the other an insoluble solid, heavier than the liquid. Example, mud and water. If muddy water is allowed to stand undisturbed for some time in a beaker, the particles of earth, that one is clay and sand, settle at the bottom, leaving a clear liquid at the top. This process is called sedimentation. The clear liquid at the top, which is water in this case, can be gently transferred into another beaker. This process is known as decantation. This process of separation involving sedimentation and decantation has, however, only limited applications. Another process of separation is crystallization. This method is most widely used for the separation and purification of solid substances. In this process, the impure solid or mixture is heated with the solvent, that one is suitable liquid, example alcohol, water, acetone, chloroform, to its boiling point, and the hot solution filtered. The clear filtrate is cooled slowly to room temperature. When the pure solid crystallizes out, this is separated by filtration and dried. For the separation of more complex mixtures, fractional crystallization is used, in which the components or the mixture crystallize out at different intervals of time. Next one is filtration. This is a process for quick and complete removal of solid suspended particles from a liquid or gas by passing the suspension through a filter. The filter is made of a porous material such as paper or fine glass wool, which prevents solid particles from passing through. The industrial and common applications of this process are purification of the domestic water supply by filtering river water through a layer of sand and gravel in a filter bed, removal of solid particles in the engine oil in car engines by air filters, filtration of tea from tea leaves in the preparation of tea, etc. Okay. Another point is evaporation. If a solution of a solid substance in a liquid is heated, the liquid gets converted into its vapor and slowly goes off completely. This process is called evaporation and takes place at the surface of the liquid. Some examples of evaporation in daily life are evaporation of water in summer from ponds, wells and lakes, and preparation of common salt from seawater by evaporation of water. Okay, the next one is distillation. The conversion of a liquid into its vapor on heating and then cooling the vapor back into the liquid is called the distillation. In this process, both evaporation and condensation take place. It can be used to to separate a volatile substance from a non-volatile one. It is used to separate distilled water from ordinary water. The next one is fractional distillation. This process is similar to the distillation process except that a fractionating column is used to separate two or more volatile liquids which have different boiling points. The industrial applications of fractional distillations are separation of petrol, diesel, oil, kerosene oil, heavy oil, etc. from crude petroleum, separation of oxygen, nitrogen, inert gases and carbon dioxide from liquid air, manufacture of spirits such as whiskey, gin, rum and brandy. Okay student, so today we discussed about matter and its nature, its classification, composition of earth, elements, compounds, some important elements and compounds, and then mixtures and various type of mixtures and how to separate mixtures. Okay, different type of separation process is known as sublimation, sedimentation and decantation, crystallization, filtration, evaporation, distillation and fractional distillation. Okay, so from today's class I think you students all understand very well. Okay, and next class we will discuss about more topics. For today, up to this much. Goodbye, take care. Okay.